So, hello everyone. In this tutorial, I will be going to explain you the SDN, that is Software Defined Networking. First of all, we will look into the introduction part. Then we will shift to the benefits of SDN. Then we will look into the SDN architecture and its components. Then to the challenges and limitations of SDN, then its real-world applications, and in the end, we will look in the future developments in the field. So, in the introduction part, we can say that SDN is an innovative approach to network architecture that separates the control plane from the data plane, allowing for more flexible and efficient network management. Traditionally, network devices such as routers and switches have been responsible for both controlling and forwarding network traffic. With SDN, the control plane is centralized in a separate controller which communicates with the data plane devices to dictate how traffic should be forwarded. Basically, with the SDN, you do not need to have an additional control plane in each and every router in the network. So, what are the benefits of SDN? Why it is needed? One of the primary benefits is its ability to simplify network management and reduce operational costs. By centralizing control, administrators can easily configure and manage the entire network from a single interface. SDN also enables greater flexibility and agility in network design, allowing for rapid deployment of new services and applications. Additionally, it provides enhanced security through granular policy enforcement and real-time threat detection. So, what is the architecture and components of SDN? The architecture of a SDN is composed of three main components: the application layer, the control layer, and the infrastructure or the physical layer. The application layer contains the software application that interact with the network, while the control layer consists of the centralized controller and its associated software. Finally, the infrastructure layer comprises the physical network devices that forward traffic according to the instructions provided by the controller. These devices are typically programmed using open protocols such as OpenFlow, which enables communication between the controller and the data plane devices. So, what are the challenges and limitations of this software-defined networking? As you know that each and every asset comes with its fair share of risks, so is the case with the SDN. And one of the primary concerns is the potential for a single point of failure in the centralized controller. If this device were to fail or become compromised, the entire network could be impacted. Another challenge is the complexity of implementing SDN in existing networks, particularly those with legacy hardware and software. This can require significant investment in new equipment and training for IT staff, which can leverage the cost and the resources for the company, which many companies might find unsuitable or not worthy. So, what are some real-world applications of this SDN? SDN has numerous real-world applications ranging to a variety of industries. It can be employed in the healthcare sector where it can be used to improve patient care by enabling faster access to critical medical information. In the finance sector, it can enhance security and compliance by providing greater visibility to network activity. Whereas in the telecommunications industry, SDN can enable more efficient use of network resources and improve quality of service. Finally, in the cloud computing, it can provide greater scalability and flexibility in managing virtualized environments. What are the future developments in SDN? As SDN continues to evolve, there are several areas of development that hold promise for the future. One of these is network virtualization, which allows multiple virtual networks to run on a single physical infrastructure, improving efficiency and reducing costs. Another area of focus is the integration of AI or artificial learning and ML machine learning into SDN, enabling more intelligent network management and automation. Finally, the emergence of hybrid technology is expected to drive increased adoption of SDN in telecommunications and other industries. So here we will put an end to the topic SDN, or software-defined networking. Next, we are going to look into Internet of Things, or IoT. So in the IoT part, we are just done with the SDN, software-defined networking. Now we are going to shift to the IoT, or Internet of Things. Basically, IoT can be said as the connected world, or we are going to explore the wonders of IoT in this tutorial. First, we are going to start with introduction, then we will jump on to the benefits and challenges. Later in the video, we are going to cover the applications of IoT, future of IoT, and then we are going to conclude the topic. So, to begin with, the introduction part, the IoT is a term used to describe the growing network of physical devices, vehicles, home appliances, and other items embedded with electronics, software, sensors, and connectivity capabilities that enable them to connect and exchange data over the internet. The concept of IoT has been around for decades, but it has gained significant momentum in recent years due to advancements in technology, particularly in wireless networking, cloud computing, and AI. What are some benefits of IoT? IoT offers numerous benefits, including increased efficiency, improved safety and security, and enhanced convenience. For example, IoT-enabled smart homes can automatically adjust temperature and lighting based on occupants' preferences and habits, while IoT-connected factories can monitor production processes in real time and optimize operations to reduce waste and downtime. What are some challenges related to the field of IoT? As we discussed with the SDN part, same is the case with IoT. It has also brought in some really its fair share of risks like security and privacy concerns, interoperability issues, and the sheer volume of data generated by IoT devices. As more and more devices become connected to the internet, there is a greater risk of cyber attacks and data breaches, which could have serious consequences for individuals and organizations alike. What are some applications of IoT? IoT has numerous applications across a wide range of industries, from healthcare and agriculture to transportation and manufacturing. For example, IoT-enabled medical devices can monitor patients' vital signs and provide real-time feedback to healthcare providers, while IoT-connected sensors in agriculture fields can help farmers optimize crop yields and conserve resources. What is the future of IoT? The future of IoT looks very promising, with experts predicting that the number of connected devices will continue to grow exponentially in the coming years. Advancements in the areas such as 5G networks, edge computing, and machine learning are expected to further enhance the capabilities of IoT devices and enable new applications and use cases. To conclude the topic, we can say that IoT is a rapidly evolving technology with the potential to revolutionize the way we live, work, and interact with our surroundings. While there are certainly challenges and risks associated with IoT, the benefits and opportunities it presents are too great to ignore, and it is likely to play an increasingly important role in our lives in the years to come. And we have concluded the IoT topic. Now we are going to shift to the network security. So now we are going to look into the network security, as I said in the IoT part. So to begin with, we will shift to PPT mode, and then we are going to look first into the introduction part and to the types of network security threats, network security measures, challenges in the field, and the best practices for the field, and then we will conclude the topic. To start with, we can say that network security is the practice of protecting computer networks from unauthorized access, misuse, modification, or denial of service. It involves the use of various technologies and techniques to secure network infrastructure, data, and communication. The importance of network security cannot be overstated in today's digital age where cyber threats are becoming more sophisticated and frequent. A breach in network security can result in significant financial loss, damage to reputation, and even legal consequences. What are the types of network security threats? There are many types of network security threats, including malware, phishing attacks, password attacks, denial of service attacks, or they are also called DOS attacks, and the man in the middle attacks or MIMT attacks. Malware is any software designed to harm or exploit a system, while phishing attacks use social engineering to trick users into revealing sensitive information. Password attacks involve guessing or cracking passwords to gain unauthorized access to a system, while DOS attacks overwhelm a network with traffic to make it unavailable to legitimate users who are in need of that particular resource. Whereas MIMT attacks or man-in-the-middle attacks intercept communication between two parties to steal information or modify data. Moving on to some measures which we can take to prevent these attacks on our systems. We can aware organizations or organizations can get aware by implementing various measures such as firewalls, antivirus software, intrusion detection systems, virtual private networks, and encryption. Firewalls monitor and control incoming and outgoing network traffic, while antivirus software detects and removes malware. Intrusion detection systems monitor network activity for signs of unauthorized access or malicious behavior, while virtual private networks or VPN provide secure remote access to a network. Encryption involves scrambling data so that it can only be read by authorized parties with the correct decryption key. Moving on to some challenges in the field of network security. Despite the availability of network security measures, there are still many challenges in securing computer networks. One challenge is the constantly evolving nature of cyber threats, which require continuous updates and adaptations to security measures. Another challenge is the human element, as users may inadvertently compromise network security through weak passwords, social engineering, or other mistakes. Additionally, the increasing use of mobile devices and cloud services has created new vulnerabilities and attack vectors. To conclude with, we can inform or we can aware the citizens or the organizations to about the best practices to secure the network or secure the data. To address the challenges in network security, organizations can follow best practices such as implementing strong passwords policies, like including uppercase, lowercase in their password, or like setting the password limit to a minimum of 8 to 10 characters, and avoiding the commonly used passwords, and by providing regular training for employees and regularly updating and patching software and hardware. Other best practices include limiting access to sensitive data in systems, using multi-factor authentication, and regularly backing up data to prevent loss in case of a breach. By following these best protocols and best practices, organizations can improve their network security posture and reduce the risk of cyber attacks. To conclude with, we can say that network security is a critical aspect of modern computing and requires constant attention and adaptation to stay ahead of evolving cyber threats. By implementing best practices and utilizing various security measures, organizations can protect their networks and sensitive data from unauthorized access and exploitation. However, it is important to remember that network security is not a one-time fix but an ongoing process that requires vigilance and proactive measures to stay ahead of potential threats. So, with this, I'm going to conclude the three topics that I have discussed here today. Hope you liked and your doubts are cleared. If you have any doubt, you can also comment in the comment section below. I will try my best to answer those. Thank you.